For our eighth lesson, what we're going to do is take a look at the midpoint formula. And the midpoint is going to be pretty important as we move forward in geometry. And so we're just going to go back a little bit and review what we should already know. So in exercise 1, it says in the diagram below, segment CD bisects AB at point M. Based on the information given, M is the midpoint of which of the two segments? And so it looks like M is the midpoint of AB, but not CD, because M is closer to D on this segment than it is to C. But it looks like AM would be congruent to BM, so M is the midpoint of AB. And then explain why, we'd just say something about it's in the middle. And then which two segments must have the same length based on the givens, and make a formal statement of congruence. And so that would be, if M is the midpoint of AB, then AM must be congruent to BM. And that goes back to what we looked at when we talked about our proofs. So midpoints have a special place in coordinate geometry as well. And so basically, if we're looking at the graph, we have segment MN, and it contains point P. We're going to use the distance formula to prove that P is the midpoint of MN. So if P is the midpoint of MN, then the distance from M to P should be the same length as the distance from P to N. So I'm going to find the distance of the segment that goes from M to P, and then I'm going to find the distance of the segment that goes from P to N. Alright, so to find the distance from M to P, I'm going to use those 2 points, M and P, and my distance formula is the one with the big square root, and then under there I have x minus x, so I'll do 10 minus 2, and I'll square that. And then in the same order, I have to do y minus y. So 9 minus 3, and then square it. And we'll simplify that. 10 minus 2 is 8. 9 minus 3 is 6. And if we square those, we get 8 squared is 64. 6 squared is 36. And then we add them together and we get the square root of 100, which is 10. And now we're going to do the same thing from P to N. So again, my distance formula is big square root x minus x, so 18 minus 10 squared, and then plus my y values subtracted, so 15 minus 9, and again we're going to square those. So 18 minus 10 is going to give us 8, 15 minus 9 is going to give us 6, and so again we get 64 and 36, add them together, and we get the square root of 100, which is 10. So we proved that MP is the same length as PM, which means that P is the midpoint. All right, so our third example, we're given 2 points, M and N, and those are the same points that we had in exercise 2. And we want to find the average of their x coordinates and the average of their y coordinates, and then it says, what do you know about these 2 points? Well, average is when you add things up and divide by how many you have. So if I were to find your test average, I would add up all your tests and divide by the number that you have. So what I'm going to do here is I'm going to average my x coordinates. So I'll do 18 plus 2 and divide by 2. And so 18 plus 2 is 20. And then 20 divided by 2 is going to give me 10. So those are my x coordinates. And for my y coordinates, I'm going to do the same thing. So I'm going to add 15 plus 3, divide by 2, and 15 plus 3 is 18, and divided by 2 is going to give me 9. Now, if I look at this point P right here, this is my origin, and so that point P has coordinates 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that point P has coordinates 10, 9. So if I know my 2 endpoints, and I find the average of the x's, and I find the average of the y's, that will give me the coordinates of my midpoint. Alright, so on the back, our midpoint formula is the average of the x's and the average of the y's, so x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. And it's always in a point format, so always in parentheses with a comma in between, because if you have a point, it's always going to be given to you in parentheses with a comma in between, so you know that your first value is your x value, second value is your y value. So in the next exercise, we have 2 points and we want to go ahead and find the coordinates of the midpoint. So for the midpoint for this one, I'm going to add my x values together and divide by 2, and then I'll add my y values together and divide by 2. And so now I have negative 5 plus 9, which is going to be 4, and divide by 2. And then 7 plus 15 is going to give me 22, and then I'll divide by 2. So if we simplify that, 4 divided by 2 is 2, and 22 divided by 2 is 11, and so 211 is the coordinates, would be the coordinates of the midpoint of that segment. All right, so see if you can go ahead and try B on your own. Try that one and see if you come up with the correct answers. All right, so there's another way that you can take a look at finding midpoint, and that's if you have a graph, or if you don't have a graph, if you're willing to take the time to plot the 2 points. Basically, if I have this segment here and I want to find the coordinates of the midpoint, I can work it off to the side and find the average of the x's, average of the y's, but if you think about turning it into a right triangle again, to go from A to B, I'm going to have to travel up 10 units and then over 4. So to travel the whole way from A to B, I would travel up 10 units and over 4. But I only want to go halfway because I want to find the midpoint. So instead of traveling up 10 units and over 4, I'm going to travel up 5 and over 2, and then that point right there is going to be my midpoint. So the coordinates of that point would be 1, 2. So point M has the coordinates 1, 2. And again, I could have done that out on paper with using my formula, find the average of the x's, average of the y's. But if you have graph paper, sometimes it's just as easy to count the boxes and actually find it. All right, so what is the slope of AB then? Well, if I went up 10 units and over 4 to go from A to B, my slope of AB would be up 10 units and over 4. And I can simplify that. I can take a 2 out of everything. And so my slope would be up 5 and over 2. Now, if I want to find the perpendicular bisector of segment AB, I basically need to come up with the equation of a line that has the opposite reciprocal slope of AB, and it has to go through the middle of that segment, which is that point 1, 2. So if this line AB has a slope of 5 over 2, my new line has to have a slope of negative 2 over 5. So from this point M, basically I'm going to go down 2 units and over 5, and I can do that a couple times. And so I have the line. This is my line. I'll draw it in. But I need to write its equation. So here's what I know. I know that it has to have a slope of negative 2 over 5, and I know that it has to go through the midpoint, which is point M, whose coordinates are 1, 2. So because I have a slope and a point, I'm going to use point-slope form of the line. So y minus 2 equals my slope times x minus the x value of my point. And then I can just go ahead and leave it right like that. That would be the equation of the perpendicular bisector in point-slope form. Okay, if they wanted it in slope-intercept form, I'd have to move the 2 over, distribute, clean it up, but it just says state its equation, and that is an equation. And then for the last part of this, it says state one point other than M that the perpendicular bisector passes through. Mark this point as D on the graph, and then we're going to show AD and BD, and we're going to look at their lengths, use the distance formula, and see what we observe. So we have a bunch of points on this segment. I'm going to go with this one right here, and that's going to be my D. So its coordinates are 1, 2, 3, 4, 5, 6, 0. And so now what I want to do is I want to find the length of the segment that goes from A to D, so that segment there, and I want to find the length of the segment that goes from A to B, or D to B. So to find the length, I'm going to use my distance formula. Now A has coordinates negative 1, negative 3, and D has coordinates 6, 0. So to find the length, I'm going to take the square root of my x values subtracted, so negative 1 minus 6 squared, and then my y value subtracted, so negative 3 minus 0 squared. And then we'll clean it up. So we have negative 7 squared, negative 3 squared. And remember, when we square negative numbers, remember we said we would not end up with negative answers. So negative 7 squared is negative 7 times negative 7, which is a positive 49. And then negative 3 squared is going to be a positive 9. And when we add those together, we get the square root of 58. So now what I'd like you to do is find the length of BD. B has the coordinates 3, 7, and D has coordinates 6, 0. All right, so hopefully you found the length of BD, and that segment should also have a length of the square root of 58. And I can leave it right like that. I could change them into decimals or simplify or whatever, but if I leave them as the square root of 58, I see that they're the same. So what is my observation? My observation is that from any point on the perpendicular bisector to the endpoints of the segment are going to be the same length. So basically I can simplify that as AD is the same length as BD, or AD is congruent to BD.